Suppose we have 3 glasses and 10 coins. The problem is to place odd number of coins in each glass. That is, each glass should contain coins and the number of coins in each glass must be odd and total coins which will be used must be equal to 10. Let me repeat the puzzle. Suppose we have 3 glasses and 10 coins. The problem is to place odd number of coins in each glass. That is, each glass should contain coins and the number of coins in each glass must be odd and total coins which will be used must be equal to 10. Feel free to pause the video and try yourself before checking the solution. This is one of the fantastic puzzle asked in the job interviews. Let's check the solution now. See, it is not possible to use all 10 coins with each glass having odd number of coins. This is because if you add odd number of coins odd number of times, then the result is always odd but not even. But here there are 10 coins which is even. That is the challenge here. There are even number of coins but number of glasses are odd. Therefore we must think out of the box. Let's solve now logically. So in the first step, in the first glass place 5 coins which is odd. After that, in the second step, in second glass place 2 coins and in the third step, in third glass place 3 coins which is odd. Here the first glass contains 5 coins which is odd, second glass contains 2 coins which is even and the third glass contains 3 coins which is odd. Now is the important step. After third step, glass 1 has 5 coins, glass 2 has 2 coins and glass 3 has 3 coins. Now place the entire third glass inside second glass. By doing this, we are making sure that the second glass has 5 coins. Hence indirectly, now second glass contains 5 coins which is odd in nature. The scenario comprises of a wobbly bridge and 4 people. It is the night time and the people have only one torch. Without torch, one may risk his life in crossing the bridge. Also, we have a condition. The bridge is not quite strong and can hold only 2 persons together at once. The 4 people take different time to cross the bridge. The timings are 1 minute, 2 minutes, 7 minutes and 10 minutes. Since the torch is a necessity and the bridge can't hold more than 2 persons at a time, 2 persons must travel at a time, out of which one must return with the torch so they don't risk their life crossing in the dark. What is the shortest time that will be required for all of them to cross the bridge? Let me simplify the puzzle. 4 people need to cross a bridge at night. Unfortunately, they have only one torch and the bridge is too dangerous to cross without one. The bridge is only strong enough to support 2 people at a time. Not all people take the same time to cross the bridge. Times for each person is 1 minute, 2 minutes, 7 minutes and 10 minutes. For example, if the 2 people with the speed 7 and 10 minutes were to cross together, it would take 10 minutes, leaving 17 minutes for one of them to return and get the rest moving. Can you find what is the shortest time needed for all 4 of them to cross the bridge? This is a very famous interview puzzle asked in several job interviews. Feel free to pause the video and give a try before checking the solution. Were you thinking of using the fastest person who takes 1 minute to travel to and fro till everyone has reached the other end? Yes, that can be done, but it will take 10 plus 1 plus 7 plus 1 plus 2 equals 21 minutes in total. If you pay attention towards finding a way to merge the one taking 7 minutes and the one taking 10 minutes, we will have to acknowledge the fact that one of them will also have to return back, which will take much more time than 21 minutes. What if we use the person taking 2 minutes to escort the one taking 1 minute across. Let's come to the conclusion. So in first step, 192 crosses the bridge and 2 returns with the torch. Here time taken is 2 plus 2 equals 4. In the second step, 7 and 10 crosses the bridge and one who was already in the other side come back. Here time taken is 10 plus 1 equals 11. In the final step, 192 crosses the bridge. Here time taken is 2 minutes. In such a manner, the total time taken will be 2 plus 2 plus 10 plus 1 plus 2 equals 17 minutes. Alternatively, the same time can be achieved like this. 1 and 2 go first, then 1 comes back, then 7 and 10 goes and 2 comes back, then 1 and 2 go again. It makes a total of 17 minutes. You have 10 boxes that contains balls with each of the ball weighing 10 grams precisely. Now among the boxes, one of the box comprises of defective balls with each defective ball weighing 9 grams. You have been provided with an electronic weighing machine, but you are allowed to use it only once. Can you find the box with the defective balls? The puzzle looks difficult, but by the time you understand the solution, you will find that it was way easy than you were thinking. For convenience sake, let's name the boxes from 1 to 10. In order to solve this problem, you have to leverage the fact that you know exactly what each good ball is supposed to weigh and what each defective ball is supposed to weigh. Many of us instinctively will take one ball out of each box and try to find a way to make it work, but the trick is to take different number of balls from each box. The number of balls you pick from each bag is equal to the box number. For example, pick 1 ball from box 1, 2 balls from box 2, 3 balls from box 3, and so on, and finally 10 balls from box 10. In total, you will have 55 balls. If all of the boxes have good balls, then the total weight of these balls would be 1 plus 2 plus 3 plus till plus 10 times 10, which is equal to 550 grams. This is because each ball weighs 10 grams. 550 grams is not possible because we are already told in the puzzle description one of the box comprises of defective balls with each defective ball weighing 9 grams. So this is the catch to solve this puzzle. If box 1 has defective balls, then the total weight should be 1 gram less than expected. It is because only one ball weighing 9 grams. If box 2 has defective balls, then the total weight should be 2 grams less than expected. It is because 2 balls weighing 9 grams. Similarly, if box 3 has defective balls, then the total weight should be 3 grams less than expected. It is because 3 balls weighing 9 grams. So once you weigh the set of chosen balls, find out the difference between the total weight and the expected weight. That number represents the box number which contains the defective balls. By following these simple steps, we can solve this puzzle and defective box can be identified with single weigh. You are given 8 identical looking balls. One of them is heavier than the rest of the 7. All the others weigh exactly the same. You are provided with a simple mechanical balance and you are restricted to only 2 uses. Can you find the heavier ball? Let me repeat the puzzle. You are given 8 identical looking balls. One of them is heavier than the rest of the 7. All the others weigh exactly the same. You are provided with a simple mechanical balance and you are restricted to only 2 uses. Can you find the heavier ball by using only 2 uses of the mechanical balance? Let me explain the solution now. For convenience sake, let's name the balls 1 to 8. First, we weigh 1, 2, 3 on the left and 4, 5, 6 on the right. This is the first measurement. There are three scenarios which can arise from this. Let's consider the scenario 1. If the left side is heavier, then we know that one of 1, 2 or 3 is the heavier ball. Now in the second measurement, weigh 1 on the left and 2 on the right. We will know if 1 or 2 is heavier. If they balance out, then 3 is the heavier one. Thus, heavier ball is identified by exactly two measurements in this scenario. Let's consider the scenario 2. If the right side is heavier, then we know that either 4, 5 or 6 is the heavier ball. Now in the second measurement, weigh 4 on the left and 5 on the right. By doing this, we will know if 4 or 5 is heavier. If they balance out, then 6 is the heavier one. Thus, heavier ball is identified by exactly two measurements in the scenario 2. Let's consider the final scenario, that is scenario 3. If 1, 2, 3 and 4, 5, 6 balance out, then we know either 7 or 8 is the heavier one. Weigh both of them to find out which one is heavier. Again here, heavier ball is identified by exactly two measurements. Let me summarize. The first step is determining which set of 3 balls contains the heavier one. So choose balls 1, 2, 3 and balls 4, 5, 6 and weigh them. If one set is heavier, save those 3 balls. Pick 2 balls and place for measurement. By doing this, we will know which one is heavier. If they balance out, then other is the heavier one. If neither side is heavier in the first step, proceed with balls 7 and 8. In the final weighing, weigh both of them to find out which one is heavier. By following these simple steps, we can find which ball is heavier in just 2 measurements. Think that you have 2 identical ropes, which are non-uniform in composition. Each rope takes 60 minutes to burn, but the ropes are not identical, meaning 90% of the rope may burn in 5 minutes and rest 10% may take 55 minutes or any such composition. You don't have any watch but a lighter. How will you calculate 45 minutes? So I will repeat the puzzle. You have 2 identical ropes which are non-uniform in composition and each rope takes 60 minutes to burn, but their composition is non-uniform, meaning 90% of the rope may burn in 5 minutes and rest 10% may take 55 minutes, or 80% of the rope may burn in 5 minutes and rest then may take 55 minutes, or any such composition. You don't have any watch but a lighter. So the question is, how will you calculate 45 minutes? As it is told in the question, the ropes are non-uniform. It means that if you cut a rope in 2 halves, then both halves may not take 30 minutes each to burn. But on a whole, the rope will take 60 minutes to burn. This approach is not going to help. So in order to calculate 30 minutes, you only need one rope. So what you can do is burn the rope from both ends. It will take the rope 30 minutes to burn completely. Even though it is non-uniform, but if you burn on both the sides, it's definitely going to take 30 minutes because the composition does not matter since you are not burning the rope from one side. So in order to calculate 45 minutes, the one rope is not sufficient. You need 2 ropes. Let's call the ropes A and B and follow the below process in order to measure 45 minutes. What you have to do first is burn rope A from both ends and rope B from one end. So rope A will completely burn in 30 minutes. So because it is put on fire from both the ends. As we saw in the question itself, the rope takes 60 minutes to burn. Since you are burning on both the sides, the whole rope will burn in 60 minutes. So when rope A is burnt completely, you have already measured 30 minutes. but the rope B would have burnt for 30 minutes. It does not mean that the rope B is off burnt, but it has already taken 30 minutes and the remaining portion of the rope will burn in another 30 minutes. So at this point, lit the other end of rope B as well. It will take another 15 minutes for rope B to burn completely. So that's how you are going to measure 45 minutes. So I will repeat the solution. So what you are supposed to do is first burn rope A from both ends and rope B from one end. So rope A will completely burn in 30 minutes because it is put on fire from both ends. When rope A is burnt completely, rope B would have burnt for 30 minutes. So it does not mean that rope B is off burnt. At this point, lit the other end of rope B as well. It will take another 15 minutes for rope B to burn completely. So that's how you have measured 45 minutes. A farmer lives on a small plot of land next to a river. One day he travels across the river in a small boat and purchases a fox, a chicken, and a bag of corn from a feed and supply store. When the farmer returns to his boat to cross the river again and go home, he realizes he has a problem. The farmer can only take one item in his small boat at a time, otherwise, he risks capsizing. He cannot leave the fox alone with the chicken because the fox will eat the chicken. He cannot leave the chicken alone with the corn because the chicken will eat the corn. How does farmer will cross the river without losing anything? A farmer lives on a small plot of land next to a river. One day he travels across the river in a small boat and purchases a fox, a chicken, and a bag of corn from a feed and supply store. When the farmer returns to his boat to cross the river again and go home, he realizes he has a problem. The farmer can only take one item in his small boat at a time, otherwise, he risks capsizing. He cannot leave the fox alone with the chicken because the fox will eat the chicken. He cannot leave the chicken alone with the corn because the chicken will eat the corn. How does farmer will cross the river without losing anything? First, the farmer must take the chicken across the river, leaving the fox and corn alone together on the starting side. This is a good move because fox will not eat corn. Then the farmer goes back and gets the fox. When he takes the fox across the river to the other side, instead of leaving the fox alone with the chicken, he swaps them out and takes the chicken back to the starting side. In the starting side, he then swaps the chicken out for the corn and brings it across, leaving the fox and corn alone on the far side. Finally, he goes back to get the chicken, bringing all three items across the river to the far side without letting anything eat anything else. By following this simple logical approach, farmer brought all three across river without losing anyone. You are a king of an empire. You have a servant working in your palace. He works all the 7 days and you only pay him in the form of gold bar. You must pay the worker for his work every day at the end of the day. If you are only able to make 2 breaks in the gold bar, how will you pay the servant if the servant works for the equal time every day and thus equal amount must be paid at the end of the day? If you are thinking of how to cut in such a way that you are able to make 7 equal pieces, you are thinking in the wrong direction. You should give more stress on how to make the transactions with the worker. So the trick is not to try and how to cut in such a way to make 7 equal pieces, but rather to make transactions with the worker. Make 2 cuts on the gold bar, such that you have the following sizes of bars. Bar A should be 1/7 of the bar, bar B should be 2/7 of the bar, bar C should be 4/7 of the bar. Let's check whether it is going to work. When the day 1 ends, give bar A to the worker. Here you remain with bar B and bar C. Worker possess bar A. When the day 2 ends, give bar B to the worker and take the bar A back. Here you remain with bar A and bar C. Worker possess bar B. When the day 3 ends, give bar A to the worker. You remain with bar C. Worker possess bar A and bar B. When the day 4 ends, give bar C to the worker and take back bar A and bar B. Here you remain with bar A and bar B. Worker possess bar C. When the day 5 ends, give bar A to the worker. You remain with bar B. Worker possess bar A and bar C. When the day 6 ends, give bar B to the worker and take back bar A. Here you remain with bar A. Worker possess bar B and bar C. When the day 7 ends, give bar A to the worker. Here you remain with no bar. Worker possess bar A, bar B and bar C. Thus by the end of 7 days, you have taken care of everything. This is a clever logical interview puzzle. 99% of the people fails to answer this. If you are lucky, you can get the same question and you can answer in less than a minute. You are standing before two closed doors. One of the doors leads to heaven and the other one leads to hell. Two watchmen are standing, one in front of each door. You know one of them always tells the truth and the other always lies. But you don't know which watchman tells the truth and who is the liar. You can ask only one question to one of them in order to find the way to heaven. What will you ask? Let's check the solution now. The solution to this puzzle is you should go to any one of the watchmen and ask him, if I ask the other watchman about which side leads to heaven, what would he answer? If you ask a direct question, which door leads to heaven, then the honest one will tell the truth and the liar watchman will point toward the door that leads to hell. But here we are not asking the direct question, we are asking one watchman about how the other will answer. Let me explain how this particular solution holds good for this situation. If you ask the honest watchman how the other, that is liar, will answer, he knows that the liar will point towards hell. So he will tell you that the answer will be the hell's door. If you ask the liar watchman how the other, that is honest, will answer, he knows that the honest one will point towards heaven door, but since he is a liar himself, he will tell you the other door, which is the door of hell. Hence, in both the cases, irrespective of whether the watchman is honest or liar, he is pointing to the hell's door. So you can choose the other path to continue your journey to heaven. Thus, instead of asking direct question, you can achieve the solution by asking indirect questions to watchmen. Suppose you have a regular hexagon made up of matchsticks with three diagonals in it. The task is to convert the given hexagon into three equilateral triangles by moving only four matchsticks. Before actually getting into the problem, let me explain what are hexagon and equilateral triangle. A hexagon is a six-sided two-dimensional geometrical figure. The total of the internal angles of any hexagon is 720 degree. A regular hexagon has 6 rotational symmetries and 6 reflection symmetries. All internal angles are 120 degrees. An equilateral triangle is a triangle in which all three sides and angles are equal. All three internal angles of equilateral triangle measure 60 degree. Let's get into the puzzle now. Here is a regular hexagon made up of matchsticks with three diagonals in it. The task is to convert the given hexagon into three equilateral triangles by moving only four matchsticks. Let me explain the solution now. Solution can be achieved by moving 2, 4, 5, 6 numbered matches to get exactly 3 equilateral triangles. First move matchstick 4 adjacent to matchstick 7. Next move matchstick 6 adjacent to matchstick 8. Next move matchstick 5 and connect to matchstick 6 and it forms the base for the part of the triangle 3. Finally move matchstick 2 and connect to matchstick 4 and 5 which forms the complete base for the triangle 3. Now we can clearly see that there are 3 equilateral triangles. 2 triangles are formed with side equals single matchstick, whereas third triangle formed with sides 2 matchsticks.